I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Like I said, this is the second lesson we've had on congruent triangles. The previous lesson, we talked about CP, CTC, corresponding parts of congruent triangles are congruent. Now, how do you know they were congruent? The other day, I told you they were congruent. A book told you they were congruent. Now we have to worry about looking at two triangles and figuring out if they're congruent. I have three methods to prove that they're congruent. I can use side, side, side. If any triangle has three matching sides that match another triangle, then those triangles are congruent. For instance, a 5, 12, 13 triangle is congruent to a 5, 12, 13 triangle, even if one of the triangles is upside down or flipped backwards. As long as you have three sides congruent, the angles have to be congruent also. I can use SAS to prove the label and label triangles congruent. Two sides with an angle in between them. If you have two sides and an angle in between them with the same measure on both triangles, then the triangles are congruent. And the other one would be ASA, angle included side angle. Those are the three. Obviously, there's a couple I'm leaving out. Side, side, angle will not always work. And angle, angle, angle won't work. Think about an equilateral triangle. I've got one that's 6 inches by 6 inches by 6 inches. It's equilateral. Then I have another one that's 12 feet by 12 feet by 12 feet. They're not congruent. They have a similar shape, but one's a lot bigger than the other. So now I'm going to go to some illustrations to try and prove to you with the graph, with the illustration, a picture, if you will, that proves my point. Here I have two triangles. They are congruent by side, 3 marks, 3 marks, 2 marks, 2 marks, side, angles marked, side, angle, side. Now, if I move this around, are they still going to be congruent? Hey, if I keep moving them around, doesn't matter where I move them, as long as I've got a side with a side, an angle with an angle, and a side with a side, that is an angle with two included sides, SAS, it didn't matter. Now I'm going to try and prove the same thing with ASA. Two angles with an included side. I go to my picture of my congruent triangles. I have two angles. I have 2 marks, 2 marks, 3 marks, 3 marks, 1 mark on the angle. Notice that every time I move my triangles any other way, they're still congruent. They're always going to have the same shape, the two of them. Why? Because angle, side, angle is a way to get congruence. Angle, side, angle. And let's go back to the last one I have here, side, side, side. If three sides are equal on both triangles, that is, if you have a 5, 12, 13 triangle, it's still a 5, 12, 13 triangle. They would both be right triangles and they would both be congruent. Let's go with that. I have marked 1 mark, 1 mark, 2 marks, 2 marks, 3 marks, 3 marks. So in my drawing, triangle PQR is congruent to triangle LMN, and you can match those up by what we did the other day with corresponding parts of congruent triangles. But watch carefully, it doesn't matter how I move the angles, the sides are going to be equal. They're always going to be equal because side, side, side is a valid congruence. ASA, angle, side, angle, included angle, is a valid congruence. And side, angle, side, two sides with an included angle is a congruence that works for triangles. Once they're congruent, I'm assuming you can do what we did the other day and do the match up parts that match up. That is, corresponding parts of congruent triangles are congruent. So even though I only had SAS in that first set of triangles, the other side, the third side, is also congruent, and both the other angles are also congruent. No matter how you move the triangles, they're congruent. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.